Hello, I'm Fabian Lucena. You may remember me from video tutorials such as how to save energy turning off your computer, and you must keep your computer turned on in order to record a video tutorial. Before we begin, one question. How did San Martin manage to cross the Andes while he was sick? The answer will be at the end of the video. In this video, I'm going to introduce a library for working with microservices using RabbitMQ as a message broker. Here I have already prepared a project, the default project that .NET provides. I've already compiled it, started, and now in the HTTP endpoint file, we are going to run the test. I send a request and give me these simulated weather forecast values. This is an example solution that .NET provides when we create a new web project. Now we're going to convert this application into microservices. So the first thing we need to do is split it in two parts. The first part will receive the HTTP request and return the response. This must stay exactly as it is and behave exactly the same. The second part will be the specific microservices, which will receive the request through RabbitMQ, through the queue, and respond back through the queue. So we need two projects. These projects we will leave as is, and we add the second project. So we go to Add to Solution and click Add the new project. This is not a ASP.NET Core Web API application like the one we have before. Now we're going to create a simple console application, click Next and give it a name. We'll call it Demo, leave the default option and create a new project. We can see here that the new project only has one line that says Hello World. Now let's begin configuring this project. To do that, we'll use a library, one that I create by myself, because I didn't really like the ones available, so I made one that's much easier to use. This library is extremely similar to working with controllers in .NET Web Application. First go to Dependencies, right-click, and add the new package from this library. Go to Browse and search for the library RFRabbitMQRPC app. It's a library for building RPC applications using RabbitMQ as a broker. We install it. When installing, we can see it under the dependencies packages. Let's open program.cs. We remove the argument because we don't need them, and we begin building our application. First of all, var app equal RabbitMQ app.create. Then app.run. Now the application starts working using the default RabbitMQ server settings. You can configure specific options like IP, port, password, virtual host, etc. either directly in the create or in app settings. We will work with the default, so we leave it as is. Now we're going to add a controller in the same style as .NET Web API. Create a folder, controller. Inside it, we'll create a class with the same name as the example controller. Here is the class. The class must be public. We remove the top code. and we will use the primary constructor because it only needs one constructor. We add a logger, and the class must be inherited from the control class from the RabbitRPC app library. Once we do that, we create a function that will respond to the remote procedure call, RPC. The function lives inside the controller, and we assign the queue name from which this control will listen. This function will return a task result, and we will make asynchronous. We'll call it simply demo. Where do we specify the queue? As an attribute. We'll call the queue weather. We import the attribute from RabbitMQRPC app. The first thing we'll do is log that a method is being called. The method name itself is irrelevant. The important thing is the queue name. Now we need to return a value. It with the same structure that the previous example, so we copy those values exactly. We also need the DTO, which we copy into the server project and adjust the namespace accordingly. With this, the server is fully configured. All we did was specify the queue name, initialize the RabbitMQ app, and run it. Run allows us to set a callback to be executed when the application is up and running. In this case, we simply log that the application has started. We have now extracted all logic from the .NET example and move it into the microservice. Now let's work on the facade project. In the facade, we need another library to configure the client. So we go to the first project, open dependencies, manage NuGet packages, browse, and search for RFRabbitMQRPC client. This library makes it easy to call the application built with the previous library. We close some windows and add this library as a service using dependency injection. We create a RPC client instance. We pass it the options we want to use, RabbitMQ options. We can obtain configuration from the .NET Builder configuration under the RPC Rabbit section, if it exists. Otherwise, default RabbitMQ setting will be used. Once we create the client, we must start it using the asynchronous function startAsync. Since we are inside a synchronous context, we wait for the task to complete. Now we add the RPC client to dependency injection. Builder service add singleton RPC client. With this, the RPC client becomes available in all controllers and services. Next, in our controller, we inject the logger and the RPC client using the primary constructor. The previous logic we had in this controller is no longer needed, since the microservice now handles it, so we remove it. We look the request. Now the system recommends me use the callAsync function, but the callAsync function returns a lot of metadata. So we have another function call okAsync to get only the specific data. The queue name must match exactly the queue the microservice is listening on. Because the microservice now defines the type, we return an action result to keep it generic. The facade is simply a bridge between the microservice and the final HTTP client. We make a small adjustment to the project to start both servers, review the code, and remove unused using statement. In the facade, we can see the API controller attribute, and in the microservice, we also need to add the attribute RPC controller to specify that it is an RPC controller, not a web API controller. Now both servers are running. We see the microservice login that it has started, and the API facade is also running. We test the example endpoint and get the exact same response as before. Checking the logs, we see the facade received the HTTP request and the microservice handled the RPC request. If we set a breakpoint in the microservice and make another request, and we can confirm that we can debug the microservice. We can also see RabbitMQ handling two queues, one for RPC request and one for RPC response. Since we are using a single RPC client, it uses one response queue for everything. You can change this modifying how the dependency injection is configured. After reviewing the overview, we can see both test requests executed. It all seems very straightforward. It is extremely simple to start a service. You can also use dependency injection just as in .NET Core apps. Only minimal changes are required. Everything is encapsulated, so we don't need to manually configure complex RabbitMQ settings. I think it's useful and very easy to work with. If you like it, please click the like button. If you don't like it, click the like button as a protest. If you want a more complete tutorial, leave it in the comments. Please subscribe to the channel. And now the answer of the question. How did San Martin manage to cross the Andes while he was sick? Because he had the best medicine of all, his wife, Remedios.